this in, please.
Okay, so 1, 2, linear measure. We see the word linear. What do you know we're going to be talking about today?
Lines.
So we're going to be talking about lines. So keep that in mind. We're going to be talking about measures of lines. Can you measure an actual line, like the entire line? Did you ever measure that? Why not? Yeah, it's infinite. It goes on forever. So we can't put an actual number on there. So we're going to have to split these into smaller things that we can actually measure. The things that we'll measure would be line segments. Like Austin just said, I can't measure an actual line because it's infinite, but I can measure something called a line segment that's part of a line. It's got 2 endpoints, and then all the points that are in between those. Part of the line, 2 endpoints, and all the points in between those. So that's what a line segment is. So if we were going to draw one of these, I want you to do this with me. I'm going to start. Well, it would have been a line, but instead of putting the arrows at the end, I'm going to put a point here, point here. So let's say that's point A, that's point B. That's what line segments look like. Okay. So I've got an endpoint and end. When I name this, I'm going to name it a lot like I named a line, but I don't have as much choice. I have to use the endpoint. So I would call this AB, and then over the top, I'm going to put a line, just like that. Yes. And why am I not using the arrows this time? So that's how you're going to be able to tell what they're talking about when they show you the symbol for the name. It's got the arrows at the end, it keeps going. No arrows at the end, it's talking about just the segment. When we talk about the measure of line segment AB, it's always written as just capital A, capital B. So that's another way that we can symbolize this, and it means something different. If I put the line over the top, I'd read it as line segment AB. If there is not a line over the top, I read it as the measure of AB. Okay? So the line over the top talks about the physical, actual line segment. If I don't put that, that'd be like me saying measure of AB equals 8. Something I can actually assign a number to. I wouldn't say that the line segment equals 8. I'm going to say its measure equals 8. Something that we already kind of touched on when we talked about lines and how they're infinite. Betweenness of points. For any 2 points, there is another point between them. Doesn't have to be exactly in the middle. It just says that if you've got 2 points, you can always create another point that's in between those. And keep in mind, between does not mean in the middle. It can, it just doesn't have to. So once you get that, draw part of the number line. Say this starts at 0 and it ends at 1. If I did choose to go right in the middle, where am I going to be at now? Half. And if I go between 0 and a half, quarter. If I go between 0 and a fourth, I'd be at an eighth. Can I keep going? And now I'm down to a 16th, then I'd be down to a 32nd, 64th, 128th, so on, so on, so on. Would I ever really be done number-wise? No. There's always going to be another point in between any two. And it doesn't matter how small I get. Can I always get smaller? Yeah. There's never, ever an end how small you can make those fractions. Just keep making the denominator bigger, keep getting smaller. Here's a way that we can use that kind of simple idea to end up solving for some things. If you have some point M between points P and Q, that's true if and only if P, Q, and M are, first of all, collinear, and PM plus MQ equals PQ. I'm going to go ahead and sketch this one out for you too. So once you have this drawn, or sorry, written, go ahead and draw this with me. Line segment. M is between P and Q. Is M right in the middle? No, it's just in between. Not exactly halfway between, but this would still work even if it is. The easiest way that I could say this, in other words, you may want to write this down if that was kind of confusing. Look at PM. Then look at MQ. They're both parts. And what this is saying is if I add the part plus the part, what do I end up getting? The whole thing. Part plus part equals whole. And that's a really simple idea, but it's one that we're going to use over and over again in this course. If I take something and I split it up into parts, in this case 2 parts, if I add those parts together, I'm going to get the whole thing. It's pretty simple, but it's going to allow us to do quite a bit. That would be like, let's say I know that this is 4 and I know that this is 11. What does that mean as far as how long PQ is? If this is 4 and that's 11, PQ would have to be 15. So write that down. So that was a case where I do a part, I add them together, I got the whole thing. What if I knew the whole thing in one part? Let's say I told you that PQ this time is 18, and I told you that PM is 3. Could you figure out how long MQ is? Yeah. This time I've got the whole thing. I've got one part. To get the other one, I would subtract. So 18 minus 3 tells me that MQ equals 15. So you can go that way with it as well. You've got to kind of identify what you have to begin with. Do you know both parts? You know one whole and then the other part? What do you got? And then just work with it. Word that I think you've seen before, and if not, you'll get really, really familiar with it because it's one that you will see over and over again. Congruent. This time, congruent segments, we're just going to say they have the same measure. They have the same measure. We talked about the co-prefix a little bit already. What did co mean from before? See how it's popping up again? Co means same. Congruent means same measure. And that's what the definition basically is, same measure. So use that prefix to help you remember what it is. Go ahead and draw 2 segments with it. We'll make segment AB. And then we'll also make a segment CD. Try to make them the same length as best you can. No, mine probably don't look it either. That's what we're going for. 2 segments of equal length. Now I name these, and again, I name them using the endpoints. I don't really have any choice here, though. AB. And then here's the symbol for congruent. It's an equal sign, a squiggle up above it like that. And it's congruent to CD. That's the symbol for congruent. That tells you that 2 objects have the same measure. In this case, segment AB is congruent to segment CD. Yeah.
What does it mean when there's 2 squiggly lines for the equal sign?
Approximately. You mean like this?
Yeah.
That's showing that, like, let's say you got that X was 7.1472, something, blah, blah, blah. If you rounded it, you don't want to necessarily say that it's equal, so that means approximately. That's a way to indicate to someone that your answer has been rounded. And what that means, again, that is saying that AB equals CD. So write that down as well. Those are 2 completely different statements. They're very related, but they are telling you different things. The top one said that the segments were congruent. The bottom one says that the measures are equal. So you would read them differently. This one would be read as segment AB is congruent to segment CD. This one, measure of AB equals measure of CD. Constructions we're going to talk about today, and then we'll do a few of them next time. Constructions are drawings of geometric figures made without measuring tools. Made without measuring tools. We may do one today if we have time. We'll see where we're at. So if it's something that you'd use to measure, you do not use it when making construction. Such as you do not use a ruler. What do you call the thing that you use to measure an angle? Yeah, so you don't use protractors. There are no rulers, no protractors. You can use a ruler like maybe as a straight edge, but you won't actually use it to measure anything. So typically, and what we'll do in here, they're made using a straight edge, which could be our ruler or edge of your book, or edge of your notebook, whatever. A compass, and a pencil. Those are the tools that we'll use in here to make those. Straight edge, a compass, and a pencil. You know what the compass is used to make? We use those for?
Circles.
Yeah. It's what you use to make a perfect circle. Then sketches are made with no tools. Sketches are made with no tools. That's kind of important to keep in mind. Make sure you're paying attention to the directions so you don't end up doing more work than you need to. If they tell you make a construction, use the tools. If the directions say sketch, you don't need to use a straight edge, you don't need to use a compass, sketch it. And typically what I do off on the board, that's going to be a sketch. So if they tell you to sketch, I do not expect it to look perfect. I don't expect you to necessarily use a ruler. You're free to if you want to, but you do not have to in those cases. You're just going to illustrate what it looks like and get that idea in paper. First part of the homework's up there. We're going to kind of split this up a little bit. You got page 18, 1 through 8 all, 10 through 32 evens, 46 through 54 evens. We're going to go ahead and do 1 through 8 together now. And then once that's done, we'll go back and we'll finish the next section and do the same thing there. We'll start with page 18, 1 through 8 all. 10 through 32 evens. Don't put your notes away yet, but you can go ahead and get out the paper that you're going to do your homework on, and then get your books open to that page. We'll start looking at it. So first one here, we are measuring what looks like a goldfish of sorts. All we gotta do is look at it. They've already put the ruler on paper, and then we just name our answer. So when we look at that, Nick, what's that look like to you? On number 1, what's that look like to you as far as measurement?
5.8 centimeters.
5.8 centimeters. Everybody agree? I think I do too. So 5.8 centimeters, and thank you for using a unit. Have that on your answer. Don't just write 5.8. I want to know 5.8 what? Second one. Alex, what's that look like? Yeah.
3.5.
Yep, 3.5 centimeters works for me on that one. Third one, before you answer, kind of be careful. What do we switch to? Inches. So look at how many dashes there are there. What do they split those inches up into? 16ths. So look at it. Go ahead and jot down an answer for number 3, and then I'll give you mine in a second. Look at it on your own. Jot down an answer for number 3. Keep in mind, each little line there we just said was a 16th. What are we thinking? What?
Inch and 7/8.
I would agree. So 1 7/8 inch. Now the next one, they split it up into 16ths. No, and I almost kind of wonder if it's a typo in the book because they split that inch up into tenths, and do you usually do that?
No.
No, usually inches stay with 16ths, so that's kind of weird. But look at it; it'd be 1 point. Somebody shout it out. 1.3. And again, inches. So when you're working on your own, 10 through 13, same thing. Number 5. Find the measurement of each measure. Assume that each figure is not drawn to scale. That second sentence will not always be given to you, but it is something you must always keep in mind with this. They do not have to draw things to scale. So just because things look equal, should you assume they are? Unless they tell you they are, do not go with that. Don't make any assumptions. On number 5, what are we trying to find? CD. Would that be the part or a whole thing? So what am I going to do with 2 parts? Add them together. So I'm going to take 1.1 plus, what is it, 2? Okay. Add that together and I would get? So I want you to put your answer as CD equals 3.8. 3.8 what? Inches, right? Next one, number 6. Am I doing the exact same thing? What's different about it this time, Matt?
It's only 1 part.
So what do I do with the whole and the 1 part I do know? Subtract them. So I would take the 4, the whole, minus the 1.6. So what does that tell me about RS? Say again? 2.4? 2.4 what? 2.4 what? Centimeters. When you're on your own, 14 through 19, very simple. Last 2. Not really any different, just this time, what do you notice you have in your parts there? Just new. I got some variables this time, but the work does not change. Part plus part equals whole minus part equals part. So keep that in mind, it doesn't change anything here. So for 7, they've given us CB, BD, and BD. So we're looking at that figure there. So find the value of x and BC if B is between C and D. So they didn't give us a drawing, so I'm going to go ahead and make that first. So copy this with me. B is between C and D. So C and D are my endpoints. B is somewhere here in between. If you're given a problem like this and they don't give you an illustration, make it yourself. That has to be your first step. Okay? Because if you're not doing that, it makes it a lot harder to figure out what's going on, what's going to go where. If you take the time to draw it, it makes the problem so much easier. Now that I've got that, I'm just going to go ahead and write down what I know. CB, this piece here is 2x. BD, this other piece is 4x. And they also told us that BD was 12, which really simplifies the whole process. What? Yeah, so 4x has to equal 12 because that's the same thing. Divide by 4. X does equal 3. Now we're also supposed to find the length of BC. So that would be this piece right here, correct? So how long is BC?
6.
Yeah, and now we're done. Any questions on that one? Okay, one more. Number 8. Do I have a drawing? No, so I need to make it, but I'm going to use the exact same one I just did. We got C, B, D. We're still under the same set. Now we're just going to label it. CB is 4x minus 9. BD, 3x plus 5. And CD, the whole thing is, how long? 17. How can I set this up? What do we say is true about part plus part? Equals the whole. So I'm going to set up my algebra equation. Part plus part equals whole. So 4x minus 9 plus 3x plus 5 equals the 17. Here's an example of why we practiced our algebra before we got to this first chapter, because this stuff's going to pop up. So we're going to remember, when there are variables together on the same side, how do I get them together? In this case, add them. 4x plus 3x would give me, how about the negative 9 plus 5? So that was my first step. I simplified a little bit by combining my like terms. Any questions on that so far? Okay, now we're in algebra mode. How do I get the x by itself? Okay, first step, I want to add 4 to both sides. So 7x equals 21. Last step, and x equals 3. Am I done?
No.
Because what else does this problem still want?
They would
Which one do they ask for? Look at directions. Only one of them. Find x and BC. So that was the 4x minus 9. So I'm going to do 4 times 3 minus 9. 4 times 3 minus 9. So BC also equals 3. Now it's done. On a problem like that, make sure you're answering both parts. Pretty regularly, you're going to see that in this kind of class. Often you're going to find the variable first, then you're going to plug that back in to find something else. So if you just told me x was 3, that's not going to be right. So make sure you don't lose points for just not doing the easy part. Questions on anything that's up there? Think you're good to do that on your own then? All right, so you'll come back to that later. Back to the notes. 1-3. A little bit of notes, then we'll do some homework together, and then whatever time's left, I'll give you to finish up the assignments. 1-3 is purely review. There's nothing in here that you haven't done before. Distance and midpoint formulas are all that we're going to look at. When I give you your reference sheet for the test at the end of this chapter, these 2 formulas will be on there. You need to know how to use them pretty well, so the more memorized you have them, probably the better that's going to be. but you will have access to a paper that has these on there for the test and the end of course test later on. Want to talk about distance? What am I talking about? How might you describe that in your own words? What? Length is one way to think about it. What else? What if I said the distance between me and Colin? What am I thinking about? How far it is. And that's one really good way to look at it. It's how far from something you are, or in other words, length. What kind of sign does distance always have to have? You know, algebraic signs like positive or negative. Distance is always positive. Because can I have a negative distance? Doesn't really make a whole lot of sense for something to be negative feet away from me. That doesn't make a lot of sense. So we're always going to have positive numbers there. And that'll be the first part that we talk about. We're going to look at this in two forms. One-dimensional on the number line is first. And in that case, distance between 2 points is the absolute value of the difference between the points. On the number line, distance between 2 points is the absolute value of the difference between their coordinates. Backtracking on what I said just a little bit ago, why does it say I have to take the absolute value? What's that do to it? Makes it turn into what? Positive numbers. We already said distance has to be positive. That's why I use the absolute value in there. Go ahead and sketch a number line. A 0 there, -1, -2, 1, 2. We'll put 2 points there. I got A at -2, B at 3. When I find that distance, it's the absolute value of their difference, which means to which operation? Subtract. So the absolute value, remember those bars are absolute value, A minus B. Let's go ahead and just finish this one then. Where is A at? Minus, where's B? So then that becomes -2 minus 3 is? So absolute value -5, which equals 5. So there's my distance. Would it work if I did B minus A? Would I get the same number? Let's try it and see. If I do it that way, B's at 3. A is at -2, but it's minus -2, right? What happens when I subtract a negative? 3 plus 2? Absolute value 5. So does it matter? Because you're taking the absolute value of the difference, order does not matter. So don't worry about which one has to go first. Subtract them, then take the absolute value. So the distance between there is 5. Now if you really want to make sure you're right, if you got the number line, what's another way to get 5? Yeah, so you go 1, 2, 3, 4, 5. Just count those spaces. Add up how many spaces you've got, and that'll be a way to check it. Now, more often, we're going to do this on the coordinate plane. So instead of just one dimension, one line, we've got our two-dimensional graph with our x's and our y's. Man, this formula will be on your reference sheet, but the better you know it, probably the better you're going to be at working with it. I'm not going to say you have to have it memorized, but the better you know it, easier it is to work with. Yeah, this is if you're on the coordinate plane. Write that down. Make sure you do write it carefully. Don't forget about the square roots, the squares, and get all the signs right. Distance is the square root of. That goes on everything. Difference between the x's squared plus difference between the y's squared. Yeah.
If they were equal, like, would you have to square them?
Like, what do you mean if they were equal? Like if the x's and the y's were equal?
No, if both x's were equal, like, they equal, how to explain it?
Like the x's independently are equal, like
No, like x 2 is the square. Would you have to take x2 minus x1?
you're saying like this isn't here at all?
Yeah.
Like if it's 0? Then I wouldn't worry about it. You're still gonna square it no matter what. Like that has to happen. And the reason is right here I'm squaring it, but then what am I doing at the end? I'm square rooting it, which kind of cancels that out. We'll look at later on when we talk about, I think you all probably used Pythagorean theorem before, but I'm a little familiar. This is the Pythagorean theorem. Like all we're doing is doing a shortcut to get to this at the end, but that's where the distance formula comes from. When we deal with that a little bit later in the year, I'll show you that proof. Okay, midpoint formula. Now, when it's on your reference sheet, it's so easy to remember, and the way I think about it is just comparing it to something that you already know how to do pretty well. Basically, this is the average between 2 points. The average between 2 points. You all know how to take averages. You're only dealing with 2 numbers. We'll deal with 2 numbers. If I wanted to find the average between any 2 test scores in this class, what would I do with those 2 numbers? Add them and divide by 2. So if I want to find the average of 2 points, what do I do?
Add them up
And divide by?
to
Same idea. And I just do that with the x's, so x1 plus x2 divided by 2. I get my new x coordinate. Just like you all just told me, to average something, you add it, divide by how many you have, in this case just 2. So then for my y's, it's going to be the y1 plus the y2. Pretty easy stuff. You're averaging it, getting an answer. And that's if you're on the coordinate plane. If you're on the real number line, then you just don't have the y's to worry about. You just have the x's. Then last definition for today. Segment bisector. Go ahead and write down the term, but don't write down the definition yet because there's something I want to talk about before we get into that. This is another one of those words that if you look at it and break it down, it's going to make a lot of things a lot easier to remember. So the word or the prefix I want to focus on right now is bi. How many? 2. Okay. You're like bicycle, 2 wheels. Biplane. All that kind of stuff. Like that prefix does mean 2. Sector, probably not one that we're familiar with. It's a Latin word. Sect means to cut. Okay. So that base word means to cut. So what does bisector mean based on how I broke it down? Into how many parts? 2. Cut into 2 parts. So now you can go ahead and write down that definition. But again, make it a lot easier to remember the definition if you can figure it out just by looking at the word. Segment bisector means I'm cutting a segment into 2 equal parts. And that can be any segment line or plane that intersects a segment at its midpoint. Sketch a segment. So it's a segment, I've got my endpoints called A, B, and then try to put M as in the middle as you can. I'll just draw that. Put that one there. So I've got LM going through segment AB. So it's a segment bisector. The way that we show that segments are equal, we just put dashes like that. So when you see those dashes, that tells you this piece equals this piece. If I had some other figure or more than one thing here that was equal, if I put 2 here and 2 here, that tells me those match up. And you just keep doing that to match up the ones that go together. The ones match up with the ones, the twos with the twos. So I can write, using our symbols from earlier, AM, that's not an M, take 2, AM, remember what the symbol for congruent was? Did earlier today. Yeah, so AM is going to be equal to which one? MB. Again, you can have those reversed. You can only call that MA or BM. That's okay. So that's what the segment bisector does. LM went through there. It cut that into 2 equal parts, and those parts are then congruent. And there's your second part then. I'm going to go ahead and add number 3 to this, but we're going to go ahead and do it together so we have an example of that. So we're going to do number 3, and then we'll do 7 through 12 all together, and then on your own you'll have 14 through 56. And then this and the assignment from 1-2 are both due on So book's on page 30. I'm looking at number 3. Alexis, what are we finding on number 3? Find the distance. And since I'm on the coordinate plane, I'm going to use that point. So I'm going to go ahead and rewrite it. Might be a good idea to go ahead and write this at the top of your paper so that way you have it to look at. Square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I would say write that at the top of your paper because you're going to use it on a lot of these problems. That way you don't have to keep flipping back to the notes. And those reference sheets I'll probably get you for next time. Now what I do next is write down our points. I've got 4, 9, and then what's the other one? 4, 9, and -3. What I would say with these distance or midpoint ones, first step, to make it easier, write down the points and then assign which was which. So usually what I would just do is x1, y1, x2, y2. Then you don't have to think about which one goes where, you just look at what you've already written. Now we take those and we plug them into the formula. So the distance is going to equal the square root of, what did I say that x sub 2 was? 2, so that goes there. Minus, what's x sub 1? X sub 1, 4 squared. Plus, y sub 2 is negative 3 minus y sub 1, which is, and then we're going to square. Order of operations would say that I do what first? What's inside the parentheses? So I've got 2 minus 4, which is what? So negative 2 squared plus negative 3 minus 9 gives me squared. Then keep going. Order of operations next says, before I add, I need to take care of those exponents. What's negative 2 squared? What's negative 2 times negative 2? So 4 plus negative 12 squared? Are those both positive? Yeah, because squaring always makes it positive because it's a negative times a negative. Then add square root of 128. For now, since we're dealing with distance, I am okay with you getting that as a decimal. So somebody's got a calculator, real quick, type in square root of 128. Oh, yeah, thank you. I was not paying any attention. So correction, that should be 148. Thank you for noticing that. So type that in. Square root of 148, we'll go nearest 10. That's good enough on the homework, too. Yeah. Not paying attention to what you're doing. That's how. You get it, Shelby? Square root of 148 to the nearest 10th would be about. Say what?
I had 2 square roots.
Oh, yours does it automatically.
12.16.
12.16, so I'll go 12.2. You're not wrong, Shelby. I just wanted the decimal just then. And notice how, kind of bringing up what Micah mentioned earlier, why am I not putting an equal sign on that last line? Yeah, I rounded there, so I want to show that to anyone who looks at my answer.
So,
I'm blocking the board, Matt.
so
You see the thing on? No. You can move over there. Those 2 seats are pretty easy. Yeah.
So on our homework list, if we are within that.
Yeah, that's it. Any questions on distance for me then? All right, next part then. We'll look at number 7. 7 says, use the number line to find the midpoint. I'm looking for the midpoint of AC. Really easy. Where's A at? Plus, where's B at? B, or sorry, C, but yeah, you're right, because it's 6. And then what do I do to those after I add them? Divide by 2. So negative 12 plus 6 is? Divided by 2? Negative 1. There's my answer. Number 8, same idea. Where's B at? B is at? So 0 plus 18 divided by 2 would just be 9. Where's that answer? Number 9, still finding midpoint. This time I've got x and y. Add the x's together. So 5 plus 3 would give me, divided by 2, 4. Then add the y's together. Negative 3 plus negative 8 would be negative 11. Can I divide that by 2? Yeah. So you can either leave it as negative 11 seconds, or if you want to write it as a fraction or a decimal, like a mixed number or a decimal, it's fine. But see, I didn't show any work there. I'm kind of okay with that on those problems where you're just doing some arithmetic on the calculator. That's fine. 10, go ahead and do it on your own. See what you get. And if you got a fractional answer, you can leave it as a fractional. I'm always okay with that. Dylan, which come up with? Yeah, that works. So you want to change it to a decimal, 5.5, comma 0. 5.5 came from the 7 plus 4 gave you 11. 11 divided by 2 is 5.5. And then the 1 plus the negative 1 cancel out, becomes 0. 11. Find the coordinates of G if F is the midpoint. Guess what they're saying there? Are we finding the midpoint this time? They're giving us the midpoint. We're finding one of the original points. F is the midpoint, and then J has the coordinates 6, negative 2. So what we know is 1 equals, go ahead and write that. I'm just going to write like x plus 6 divided by 2. And then we'll talk about where I'm getting that from. The 1, that came from F, which is the midpoint, right? So to find that midpoint, I would add the x's divided by 2 like we're doing. I know one of the x's is 6, but I don't know the other x. But could I work backwards to figure out what that is now? How would I get rid of dividing by 2? So multiply by 2. Cancel. On the left side now I've got 2 equals x plus 6. So how do I get x?
Minus 6.
2 minus 6 gives me, so x is negative 4. So there's part of my answer. Now I'm going to do the same thing for the y's. Look at F. What's its y value? The y coordinate in point F. It was 1 comma 3.5. So 3.5 is going to equal y, and then look at the y coordinate of J. It was 6 comma negative 2, so minus 2 over 2. Now work it out the same way. How do I get rid of dividing by 2? Multiply by 2. Cancels. Do the same thing over here. If I double 3.5, I get, so 7 equals y minus 2, so y equals, add 2, y equals 9. So there's your answer. Negative 4, comma 9. Yeah.
What I was asking earlier, like if the x's are the same, you have to subtract them.
When you're doing midpoint formula, if you see that they're the same, you can just leave them alone. And with distance formula, if you see that the x's are the same, if you take a number minus itself, you're going to get 0. And 0 squared is 0. So you can kind of ignore it at that point and then just take care of the y's or whichever one you got left. Yeah, that'll happen sometimes. Okay, last one, number 12. Kind of similar. They've given us that, and we want to find the value of A. So I know midpoint is which point? In an order pair. The midpoint is what? And what's the order pair? So I'm going to work with the 6 to be honest. 6 is going to equal, what are the x coordinates of the other two? So 3a plus 3 divided by, what do I do when I find midpoint? 2. Solve for A. And notice how once we get these set up, the work's not going to change ever. The setting up's probably the harder part. How do I get rid of dividing by 2? Good. Now what do I have?
Subtract 3.
Well, before then, though, I get 12 equals and then 3a plus 3. And then you're right. Subtract the 3, which would give me, so 9 equals 3a. Divide and a equals. Am I done? What the question asked for.
What is the value of A?
So am I done?
Yes.
I could have used the 2a, the 4, and the 2 instead. There you go. So the rest of the time is yours. You get about 20 minutes to work on it.